Alright, so I'm going to show you how to use the SomaticSeq app on precisionFDA to do training and then use the classifiers built from SomaticSeq training to do somatic mutation prediction. So this is an app that was created by DNA Nexus. So I'll just show you how to do it. App, say run app. You need more of a higher memory instant type. We'll go with high memory 16. That worked. So training mode is true now. XGBoost, you need the reference file, grch38. This one, it requires the index. Over here, that, and also requires the dict file. dbSnip, you can have it, but we'll just skip it to do what's the minimal. You need the truth if we want to train, so let's use the SEQC2's reference sample and call set. HighConf, that's the high confidence SMV file for truth, and the high confidence indel file. Let's name it SomaticSeq classifier testing. And so those classifier, that's for the classifier model that's used for prediction mode. So since we're doing training, there's nothing there, leave them blank. Cosmic VCF, that's just for annotation purposes. Let's only do the training and calling in the high confidence region of the SEQC2 datasets. High confidence region. Nothing to exclude there, so we'll just leave them blank. Pass threshold. They don't mean anything in training mode anyway, but there are some parameters for XGBoost which you can change. See treat depth, number of iterations. I think it's 500 by default, but you can just leave them as is. You need the tumor BAM file. We'll use this one. Well, remember, since it's pair, tumor normal pair, make sure it's paired, and you will need the index file. Over there. Yes. And you need a normal BAM file as well. And the BAY file for that's the index. All right. Now we're only going to use 3 colors here. What's the file name there? What's going on here? It's this one, wgs.bwa. Jeez. I use this one. And Bardic. And Stroga for parent mode come in two separate files of SMV, or here SMV and indel, so make sure to include those. wgs.bwa is something is off, and same thing here, wgs.bwa. You kind of have to do it quickly before it disappears. Now here we go. Oops, what did I do? Try again. Indel, here we go. So we have Stroga output file, Bardic output file, Bardic output file here, Mutate2 output files, tumor band files. You have included the truth and XGBoost training true, so you say run app, and then it's going to run the training mode for SomaticSeq, and it'll take about 40 minutes. So let's come back after that. I'll pause it. Alright, we're back. The job is finished in 37 minutes. This is the job, and you can still see the files and the parameters and the output prefix that will be compressed will have this file name. We named it SomaticSeq classifier testing, so let's find it. Where is it? It's right here. File. Here it is. So let's download it and see what's in it. Action, download. I'll put that in the temporary directory since I'm not going to need it later, just for demoing purposes. So here it is. See what's in it. So those are the output files for SomaticSeq training, and the classifier that you can use to predict other samples are these two files, .classifier for indel and for SMV. And you can also see in text version what that classifier actually looks like. So for indel, for instance, so it's XGBoost decision trees. You have things like Stroga score if it's less than 9.7, yes, no, and XGBoost also handles missing values. So those are the files. The .classifier are the files you can use to classify other samples. And you can also see the feature importance. So one trick is that these classifiers are built based on one single pair of tumor normal band files. And the input to make those classifiers are those TSV files, right? If you look at what's in those TSV files, using those as an example, you have all those columns starting from column 1, 2, 3, 4, 5. Starting from column 6 are actually features used to build a model. The final column is the label. There is actually a way to use multiple samples to build a classifier that has more data sets in it. And for that, you probably have to do it somewhere else. So I installed SomaticSeq on my own laptop. It doesn't have a lot of memory, so you're not going to I'm not going to do it on my own laptop because data sets will be a little bit too big for that. But you can kind of see how to do it. So SomaticSeq XGBoost, right? So that is the script used to build classifiers, and you can see the options. Just double dash to see what you can do. So there are train and predict mode. So for train, let's see what are the options. So if we want to train a single classifier with many data sets in it, you can do something like SomaticSeq XGBoost train, assuming after you have installed SomaticSeq on the computer. And then you can have multiple files in it. You can do this, you can have like sample xxx, etc., etc., etc. Oh, all those will have to have TSVS in front of it to have as many files as you want. You can name it combined model classifier, and then you can specify the number of threads, 16. Tree depth default is 8. You can change that. You can change the random seed. Method by default is hist. You can change that as well. Number of iterations in the boosting rounds. And then for every other parameters in XGBoost, you can input them something like this, right? Parameter 1, value 1. So as an example, just to show, if you want max depth, you can do max depth directly here, but you can also do something like this. I don't exactly remember what are the exact keywords for it, but something like max depth, let's say 20. And then if you say I want number boost run is this the keywords, right? 200, you can do something like that, right? Random state, 23. And for that you need to do extra param. So everything after that in this format will be passed into XGBoost classifiers, and then you will create an output file that looks like this, and then you can use that for later predictions. Boom. So I'm not gonna do here. This is just to show you how to do it. So now that you have a classifier, now how would you use it for your next sample? So let's try the prediction mode in SomaticSeq. So pretend that you're looking at a different sample set, because obviously you don't want to use model created from the same sample to predict on the very same sample. It's obviously overfitting. You're memorizing the results instead of using the feature to make predictions. But this is just for demoing purposes, so let's just pretend this is a different sample. So same thing, run app prediction. Let's see, high memory 16. XGBoost, since that's what we will use to train, this is what we use to predict. It is not training mode anymore, it's false. Same thing everywhere else though. GRCH38 show up, then you kind of have to click quickly. Oh, this is very funny here. Boom. That fave file. Kind of shows up and gone. Don't know what's going on. You have to be quick today. It's not always like that. Uh-oh, you're playing with me here. Nope, since we're pretending to do a different sample, we don't know the truth. And let's give the output prefix as SomaticSeq predict mutations. We have classifiers now. We just have to upload them. Oh, I forgot to upload them, so let's do that now. Space over here, and then let's upload the two classifiers. Browse. Temp. We need to upload classifiers. Upload. Upload complete. Alright, so classifier SMB. Ensemble, that's where it starts. SNV. Let's do the same inclusion. High confidence BEF file. So in this case, these parameters will actually make a difference. So a pass threshold means that if the model gives you a 0 to 1 score greater than 0.5, then the variant call will be labeled pass. And if the 0 to 1 score is between 0.1 and 0.5, it will be labeled low quality. And if it's less than 0.1, it will be labeled reject. Everything else though should be kept the same. Keep intermediate file no, and everything else. Now pretend, of course, that it's different data sets, even though it is the same. Didn't manage to click that in time. We can actually, yeah. So let's do that. WGS ILT. Come up. That's uh-oh. Today's system is really testing how fast I can click. Here. Oh, didn't click fast enough. I should be okay. Bam, bay, paired. So mutate again. It's WGS, BWA, I believe. It's mutate too. I clicked it. And Bardic, it's WGS .bwa. Bardic, can I click? Bardic, yes, it's here. Remember, it's Joka. WGS BWA, and it's SMV. Got it, gotcha. WGS BWA dedupe. I want indel. Alright, so you have everything here. The 3 mutation output files that we have run previously. BAM files paired. All the settings are right. We have classifier as input. And let's do prediction. Run app. And it should finish in roughly the same amount of time. Now you can see the job here that's in queue. So we'll come back in about 45 minutes and see what the results are. Alright, welcome back. Now the SomaticSeq prediction job is finished in about the same time. We can click the job and see what the parameters are. So this is going to be the file name, SomaticSeq prediction mutations. Alright, let's go to the space where it was run. Files, sort by created, so it is this one. SomaticSeq prediction mutations. Let's download that and see what we have. Download. Now keep in mind that we actually used the same sample where we did the training to do the prediction. So this is not a real good machine learning practice, but we're just demoing how to run SomaticSeq App on precisionFDA. So this is the output files, and let's take a look what the output looks like. So the SomaticSeq predicted files are labeled classified, and we can just take a look at what the VCF file is for SomaticSeq classified as indel. So well, that's what it looks like. A lot of those, most of them are reject. Reject means you have a SomaticSeq probability that's less than 0.1, as we talked about in the parameter. Let's see, let's look for something that's like a pass and see what happens. Let's do this. So either a or pass. So, that is a pass call. It's a deletion, right? The reference is GAA The alternative is G. 24.6 here is the Fret scaled probability. So corresponds to something like 0.99 something. It's pass because it's greater than 0.5. And it's the MDK means M means mutek. Mutek2 has called it. D means Vardic, which means Vardic also has called it. K is Stroka, so Stroka did not call it. So you have two tools out of three that call this variant, and you can see all those metrics like depth of coverage, mapping qualities for that call. LC is linguistic sequence complexity, also in Fret scale here, and the call above is one single base deletion, where that variant is called by all three callers in it: mutek2, Vardic, and Stroka. So that's the result for prediction. And that's all for SomaticSeq Precision FDA.